So hello and welcome to the final chapter of module number 2 of the USHA PSM system. This chapter will discuss the differences between the standard-based approach adopted by USHA and the risk-based PSM approach adopted by the CCPS. So let's first state the basic differences. Number 1, USHA and CCPS provided approaches to PSM elements. USHA's are mandatory for implementation, while CCPS is only for guidance. CCPS stated 4 foundation blocks with 20 risk-based process safety elements, while USHA required 14 mandatory elements for the PSM. So now you have 20 risk-based PSM elements and USHA's are 14. I will illustrate to you the 20 risk-based process safety elements with the blocks on the next slide. Okay, so here we have the 4 blocks. They are as follows. The first block will address the commitment to process safety. The second block will address the understanding of hazards and risks. The third one will be to manage the risk. And the last one will be learning from experience. And regarding the elements, we have the first element here, process safety culture. The second one is compliance with standards, followed by process safety competency, workforce involvement, stakeholder outreach. So these are relevant to commitment to process safety. While the elements relevant to understanding the hazards and risk block are process knowledge management, hazard identification, and risk analysis. Regarding the third block, we have the operating procedures, safe work practices, asset integrity and reliability, contractual management, training and performance assurance, management of change, operational readiness, conduct of operations, and emergency management. So this is the third block. And the final block, we have the incident investigation, measurement and metrics, auditing, and management review and continuous improvement. So these are the 4 foundation blocks with 20 elements. On the next few slides, I'm going to show you a comparison between USHA and CCPS PSM approaches. Okay, so here we have the first element, which is the process safety culture. This element is adopted by CCPS and not adopted by USHA. So what is the process safety culture? Process safety culture is the combination of group values and behaviors that determine the manner in which the process safety is managed. Okay, so moving on to element number 2, we have the process safety information. Of course, it's adopted by both approaches, but it is stated by CCPS as compliance with standards. The third one here will be the process safety competency. This one is not adopted by USHA, but adopted by CCPS. And what does CCPS say about this element? It says that development and maintaining process safety competency encompasses 3 interrelated actions. Number 1, to continuously improve the knowledge and competency. Number 2, to ensure that appropriate information is available to people who need it. And number 3 will be to consistently applying what has been learned. Okay, moving on. Number 4, employee participation, the first element in USHA PSM system. Of course, it's adopted by USHA and also adopted by CCPS. But CCPS states this element as workforce involvement. Okay. Number 5 will be the stakeholder outreach. This element is not adopted by USHA but adopted by CCPS. And the stakeholder outreach means a process for seeking out individuals or organizations that can be or believe they can be affected by company operations and engaging them in a dialogue about process safety. Okay, so moving on to process safety information. Of course, it's adopted by both approaches, but CCPS states it as the process knowledge management. The 7th element will be the process hazard analysis. It's adopted by USHA and CCPS, but CCPS states it as the hazard identification and risk analysis. Moving on, the operating procedures. Of course, it's adopted by both approaches, but CCPS involves the safe work practices, okay, within the operating procedures. The 9th element will be the hot work permit. Of course, it's adopted by both approaches, but it's included within the safe work practices element that CCPS has. Okay, moving on. The mechanical integrity, of course, adopted by both approaches, but CCPS states it as the asset integrity and reliability. Contractors is adopted also by both approaches, but CCPS states it as contractual management. The training also is adopted by both approaches, but CCPS states it as training and performance assurance. The management of change is adopted without any change in the statement. The PSSR is adopted also by both approaches, but CCPS addresses it as the operational readiness. Regarding the conduct of operations, this element is not adopted by USHA, but adopted by CCPS. And here, what is meant by the conduct of operations is the execution of operational and management tasks in a deliberate and structured manner. It is also sometimes called the operational discipline or the formality of operations, and it is closely tied to an organization's culture. The conduct of operations institutionalizes the pursuit of excellence in the performance of every task and minimizes the variations in performance. Workers at every level are expected to perform their duties with alertness. Due that full knowledge, sound judgment, and proper sense of pride and accountability should be existing. Okay? Moving on. Regarding the emergency planning and response, of course, it's adopted by both approaches, but CCPS states it as the emergency management. The incident investigation is adopted by both approaches without any change in the statement. The measurement and metrics is not adopted by OSHA, but adopted by CCPS. And here, the metrics element establishes the performance and efficiency indicators to monitor the near real-time effectiveness of the risk-based process safety management system and its constituent elements and work activities. Okay? Number 19, we have the compliance audits, and of course, it's adopted by both approaches, but CCPS states it as the auditing. Number 20 will be the management review and continuous improvement. This element is not adopted by OSHA, but adopted by CCPS. And here, the management review is the routine evaluation of whether management systems are performing as intended and producing the desired results as efficiently as possible. Moreover, it is the continuous ongoing review by the management that fills the gap between the day-to-day work activities and periodic formal audits. And at last, we have here the trade secrets. This element is adopted by OSHA, but not adopted by CCPS. So, in the end, I can tell you that both approaches are quite similar to each other. However, CCPS took the risk-based analysis of all individual elements of OSHA. So I guess you should start by OSHA PSM standard, and when you feel that you have fulfilled the requirements and you have achieved good results through the compliance auditing programs, I believe you should continuously improve the system by going to the CCPS approach. I hope you all gained the best benefit out of this module. I see you on module number 3. So hello and welcome to module number 3 of the Process Safety Management course. This module will address the Process Safety Management Key Performance Indicators, or KPI. Okay, so let's start. What are the KPIs? What are the Key Performance Indicators? If we define the Key Performance Indicators, they will be as follows. They are the defining element for measuring activity, status, and performance of the process safety management in your organization. Okay, since the main goal of process safety management is to prevent release of highly hazardous chemicals along with their consequences, of course, therefore you must have something in your hand that can show you where exactly is your organization from compliance with PSM. Okay, also you need these indicators to show you that you are on the right track or not. Okay, so they are defined to be leading indicators. I believe this is something good, and lagging indicators, which is something not good. Okay, so why set the KPIs in your organization? Number 1, the KPIs will provide you information for driving improvement. It will show you whether you are on the good track or not on the good track. Okay. Number 2, it contributes in the reduction of risks of major accidents when acted upon. Okay. Number 3, it will amplify the company's existing procedures and practices, because without KPIs, you don't know how to measure the PSM quality. Okay, and furthermore, without KPIs, you might be surprised with a disaster that you could have avoided if only these indicators were existing and measured. Okay, so let's move on to the characteristics or the major characters of the KPIs. The KPIs should drive process safety performance towards improvement and learning. The KPIs should be relatively easy to implement and understood by everyone. The KPIs should be statistically valid, and the KPIs should be appropriate for the industry, company, or benchmarking. Okay, so this is just a generalized framework for the characters of the KPIs. Let's go into much detailed information about these characteristics or these characters. If we see here the characteristics of effective indicators, they will be as follows. KPIs should be reliable, repeatable, consistent, independent of outside influence, relevant, comparable, meaningful, appropriate to intended audience, timely, easy to use, and auditable. So these are the characteristics of any effective KPI or key performance indicators. So why leading and why lagging? Okay. Major accidents do not just happen by chance. We have illustrated this before, if you recall, on the incident investigation element of the OSHA PSM. Okay, they are a series of chain events that eventually lead to a disaster. So you need to know where your foot is. Okay, if you are doing okay, then you are far from the lagging indicators, and if not, you are already on the lagging indicators. Okay, so according to API recommended practice 754, the PSM KPIs are classified into 4 tiers. So as you can see from this graph, we have here 4 tiers of PSM KPIs. Tier number 1 KPI is the most lagging indicator, which leads to the event of a major accident. Tier number 2 is less lagging than tier number 1, of course. Tier number 3, I consider it in between the lagging indicators and the leading indicators. And at last, tier number 4, which is the most leading indicator, and it indicates to good process safety practices. Okay, So before we go into the illustration of KPIs, I need just to give you a quick preface about the types of containments. Basically, we have three types of containments: the primary containment, and the secondary containment, and the tertiary containment. What is the primary containment? The primary containment is a tank, vessel, pipe, truck, car, or other equipment designed to keep the material within it. Okay? The purpose of the primary containment is to store, separate, process, or transfer the material. Okay, so this is the primary containment. What about the secondary containment? The secondary containment is an impermeable physical barrier specifically designed to mitigate the impact of materials that have breached the primary containment. So if you have a loss of primary containment, just like an oil spill, this secondary containment should prevent the fluid or the liquid or the material from going furthermore. Okay, it is only a mitigative barrier. It includes, but not limited to, of course, tank, dikes, curbing around process equipment, drainage, collection systems, the outer wall of open-top double wall tanks, and so on. Okay? So we have the tertiary containment. The tertiary containment is done to ensure that the spill is confined within the area away from inhabited buildings and escape routes, and also to prevent underground contamination. It includes the design of infrastructures, slopes, curbs, and so on. So from this image, you will have that this tank is a primary containment, and this dike will be the secondary containment, and the land itself, or the infrastructure, or the road, or the slopes are the tertiary containment. Okay, so let's go to Tier 1 KPI or Tier 1 PSE. Tier 1 KPI or Tier 1 process safety event is the loss of primary containment with the greatest consequence. Okay, it represents a barrier weakness even if a secondary and or tertiary containment exists. Okay, because now the disaster have already happened. Okay, and we need to know what are the consequences of the loss of primary containment relevant to Tier 1 PSE or Tier 1 KPI. So what are the consequences of Tier 1 process safety event? Or in other words, what are the consequences relevant to the loss of primary containment with the greatest consequence? We need to know now what are the consequences. So the first one will be injury and or fatality, and this injury or fatality could happen to an employee or a contractor or a subcontractor. Number two will be the hospitalization and or fatality of third party. Number three will be the official community evacuation, including all the precautionary actions that will follow. Number four will be the fire and explosion, and the fire and explosion will lead to a damage of more than 100,000 US dollar in the coast. Number five will be a discharge of an engineered pressure relief device, such as pressure safety valve, safety instrumented system, or manually initiated emergency depressurization. And number six will be the upset emission from a permitted or regulated source. And regarding number 5 and number 6, there will be other consequences resulting from them. And the consequences will be, number A, we will have rainout. And what is the definition of rainout? The rainout can be defined as a two-phase relief with vapor and liquid. And the vent will be relieved through a vent or relief device, okay, dispersing in the atmosphere, while the liquid will fall on the ground. Number B will be the discharge to potentially unsafe location, such as inhabited buildings. And number C will be the on-site evacuation. And D will be the public protection measures, such as the road closures and so on. The last consequence of Tier 1 PSE will be the release of a material or hazardous chemical greater than or equal to the threshold quantities in any 1 hour period. Okay, so what are the classification of such material and what is or what are the threshold quantities? This will be addressed on the next few slides. So here on this table, let me just zoom in. You will find on this table 7 levels of Tier 1 process safety events. They are from T1-1 till T1-7. And for each individual level of Tier 1 process safety event, you will see the material hazard classification. And the classification will be demonstrated later on the slides. All I want to show you is that there are 7 levels of Tier 1 process safety events, and indeed there are threshold quantities that if exceeded, then the event will be treated as Tier 1 process safety events. So here, on the first level, you'll have the toxic inhalable hazard, Zone A materials. Tier 1 level 2 will be toxic inhalable hazard, Zone B materials. And regarding Tier 1 level 3, we will have toxic inhalable hazard C and D for the Tier 1 level 4. Tier 1-5 will be flammable gases or liquids with normal boiling point below 35 degrees centigrade and flash point lower than 23 degrees centigrade, or packing group 1 materials excluding acids and bases. I will identify with you the packing group classification and the toxic inhalable hazards. Don't worry about all of these details. They will come later on. I'm just showing you what are the contents of this table. Tier 1 level 6 will be liquids with normal boiling temperature or boiling points more than 35 degrees centigrade and the flash point lower than 23 centigrade, or other packing group level 2 materials excluding acids and bases. The last one, or tier 1 level 7, will be for liquids with flash points above 23 degrees centigrade and below 60 degrees centigrade, below or equal to, okay? Or liquids with flash point above 60 degrees centigrade released at a temperature and or above the flash point. Or strong acids and bases, we will see the definitions. Or United Nations dangerous goods Class 2, Division 2.2, non-flammable, non-toxic gases, excluding air, or other packing group level 3 materials. I will show you, or I will illustrate to you the meaning of all of these terms. They seem a little bit complicated, but you will know them furthermore on the next few slides. So now let's speak about Tier 1, Level 1, up to Tier 1, Level 4. These levels are for toxic inhalable hazard materials, or TIH for short. The following classification that I'm going to show you, or the following classification, as you can see here, is as per the regulations of the Department of Transportation of the United States of America. Okay, so you have here the hazard zone A, B, C, D, and you will see that the difference here will lie in the lethal concentration 50, or LC50 for short. Okay, so what is the LC50? The LC50 is the concentration of a material in air which, on basis of lab tests, is expected to kill 50% of the group of test animals when administered as a single exposure, okay? And the unit of expression regarding the lethal concentration 50 is the parts per million. So you have here for group A, the LC50 will be less than or equal to 200 ppm. So when I talk about tier 1, level 1 event, I will say that the loss of primary containment will be to a toxic inhalable hazard material which has a lethal concentration less than or equal to 200 ppm in a quantity which is approximately larger than 5 kilograms for a period of 1 hour. So this is the valid classification of tier 1 level 1 process safety event. While here you will see at the zone B that the lethal concentration will be greater than 200 ppm but less than or equal 1000 ppm, and for group C it will be greater than 1000 ppm and less than or equal 3000 ppm, and at last you will have the zone D, which has the LC greater than 3000 ppm or less than or equal to 5000 ppm. Okay, I hope this is clear. Let's move on to the next levels. We have here tier 1 level 5, which endorses number 1 the flammable gas. And what is the definition of flammable gas according to NFPA 55, the compressed gases and cryogenic fluids code? It says here that the flammable gas in a mixture of 13% by volume with air, or the flammable range with air is wider than 12% regardless of the lower limit at atmospheric temperature and pressure. Okay, so this is the definition of flammable gas, and this is what is meant here by the word flammable gas. Okay, so number B will be liquids with normal boiling point lower than or equal to 35 degrees centigrade and a flash point below 23 degrees centigrade. Okay, so what is the normal boiling point? Boiling point is the temperature of a liquid at which its vapor pressure will be equal to the standard pressure, which is 101.3 kilopascal. Okay, in other words, this is where the first gas bubble appears from a liquid. Okay, so when we say here on the definition, the liquids with normal boiling points below or equal to 35 degrees centigrade, so at this temperature or below this temperature, the liquid will give the first bubble of a gas. Okay, and you know, of course, the definition of flash point from our previous study in the OSHA PSM standard. Okay, at last, we will have the group 1 packing materials, and I'm going to illustrate the packing group classification on the next 2 slides. So let's move on. What are the packing groups? The packing groups classification is developed by UNECE, and UNECE is short for United Nations Economic Commission for Europe. Okay, and this system is developed for dangerous goods. Okay, and the classification is based on level of certain aspects of danger. You have here packing group level 1, which is for the highly dangerous goods. You have here the packing group level 2, which is for medium danger. And at last, you will have the packing group level 3, which is for low danger. Okay? So API address the packing groups based on toxicity. Okay, you have multiple levels of dangers. Okay, but the API recommended practice 754 address the packing groups based on the toxicity. Okay, so you have here packing group level 1, 2, 3. It will be here for oral, dermal, and inhalation toxicity. Okay, so you have here the lethal dose 50, which is equal to the lethal concentration 50 for group 1. Okay, it will be less than or equal to 5 milligrams per kilogram, okay? And regarding the dermal toxicity, you will have it here, less than or equal to 50 milligram per kilogram. And regarding the inhalation toxicity by dust and mist, it will be less than or equal to 0.2 milligram per liter, okay? So regarding the type of exposure, whether it is oral through ingestion, for example, and the dermal toxicity will be through exposure or skin contact, and the inhalation toxicity will be by inhaling the dust or vapor. So these are the values of classification regarding group 1 or group 2 or group 3, okay? Now, regarding tier 1 level 6, it will be for liquids with normal boiling point above 35 degrees centigrade and the flash point below 23 degrees centigrade. Or it will be for other packing group level 2 materials excluding acids and bases, okay? Okay, moving on to tier 1 level 7. You have here liquids with flash points, okay, above or equal to 23 degrees centigrade and less than or equal to 60 degrees centigrade, okay? Or it's for liquids with flash point over than 60 degrees centigrade released at a temperature above or at flash point, okay? And regarding number 2, or this point, I would like to give an example. If you have here a loss of primary containment for a liquid with a flash point over 60 degrees centigrade, but it was released at a temperature below the flash point, this cannot be taken as a tier 1 process safety event based upon quantity released, no matter the volume will be, okay? So moving on to number 3, we will have here strong acids and bases, okay? And regarding this point, we need to highlight that the pH of the acids or bases should be larger than 1 or below 12.5, okay? The pH should be larger than 1 and below 12.5, or more precisely, substances that will cause full thickness destruction of intact skin tissues within an observation period up to 60 minutes, starting after the exposure time of 3 minutes or less. Okay, regarding number 4, we'll have the UNDG Class 2 Division 2.2 non-flammable, non-toxic gases excluding air. This classification will be highlighted on the next slide, so don't worry about it. And at last, you will have other packing groups, level 3 material. Okay, so let's move on to the next slide. Here we will have the United Nations Dangerous Good classification. This classification is based according to the ADR, which is the Agreement for Dangerous Goods by Road. Okay, this is a United Nations treaty signed or ratified by multiple countries. It is well acknowledged and well recognized. Okay, so you have here all the classifications, okay, regarding from class 1 up to class 9. Okay, what does tier 1 level 7 say? It says here class 2 division 2.2. Let's go to the classification. You will have here the class 2 division 2.2 non-flammable, non-toxic gases. Okay, moving on. What are the rules for tier 1 PSE classification? First rule, that the LOPC or loss of primary containment can include non-toxic, non-flammable materials such as steam, nitrogen, hot water. So it's not exclusive for highly hazardous chemicals, okay? Number 2 will be that pressure relief devices, safety instrumented systems, or emergency blowdowns are tier 1 process safety event due to the unplanned nature of the release, okay? The third rule we'll have is that the loss of primary containment doesn't have to come first. If a fire or an explosion resulted to a LOPC, then it's tier 1 process safety event. So let's move on. The fourth rule will be that for solutions not listed in the United Nations Dangerous Goods classification, the anhydrous component shall determine the toxic inhalable hazard zone or packing group classification, and the threshold quantity of the solution shall be back calculated based on the threshold quantity of the dry component weight. Okay? And please note that for mixtures where the UNDG classification is unknown, you can take the fraction of the threshold quantity released for each component and calculate them. If the summation of the fractions is equal to or greater than 100% of the threshold quantity, then the mixture exceeds it, and you can consider it as a tier 1 process safety event. Okay? Another note that I would like to highlight is that where there are clear and independent toxic and flammable consequences associated with the mixture, then the toxic and flammable hazard should be calculated independently. Okay? Okay, moving on to the rule number 5. Okay, so regarding our notes, let's fit an example. Okay, the example here is that a pipe fitting in a specialty chemicals plant fails, releasing 4,000 pounds of a mixture of 30% formaldehyde. The formaldehyde is classified as tier 1 level 7. Okay, and methanol, 45% of methanol. Methanol is a tier 1 level 6 material, and 25% water in less than 1 hour. Okay, The mixture is not classified by the UNDG classification or United States Department of Transportation protocols. Therefore, the threshold quantity mixture calculation is applied. The pure component reporting threshold of formaldehyde is 4,400 pounds and methanol is 2,200 pounds. So how we solve this problem? Here we'll have the formaldehyde, the methanol, and water. What is the quantity of formaldehyde? He said here 30%, then the weight is 30%. The release quantity, okay, of the 30% regarding the 4,000 pounds will be here 1,200 pounds, okay? The threshold quantity of tier 1 level 7 material will be 4,400 pounds, okay? Then the percentage of the threshold quantity will be here 27.3%. Regarding the methanol, the quantity here or the weight here is 45%, okay, and the release quantity was 45% out of the 4,000 pounds, then it will be 1,800 pounds, okay. And regarding the threshold quantity for tier 1 level 6 material, it will be 2,200 pounds. Then you have a percentage of threshold quantity which is 81.8%, okay. Regarding the water, regardless of the released amount, it will not constitute any value because we are talking here about the anhydrous component, which is water dehydrated component. So you will have here the summation 109.1%, and this is of course a tier 1 process safety event. Okay, I hope it's clear. So let's move on to the calculation of process safety event. Calculation can be made on two types. Number one is the PSE rate, and this is mandatory to be done, and the optional one is the PSE severity weight. Okay, so regarding the PSE rate, here we have two equations. The selection is up to the company. You can calculate the PSE rate per 200,000 working hours, okay, or you can calculate it per 1 million working hours. So the equation is simple. You have here the total tier 1 PSE count divided by the total working hours in the organization. Okay, the outcome is multiplied in 200,000 if you are doing it by 200,000. If you are doing it per million, then the same equation apply, but the outcome here will be multiplied in 1 million. Okay, and please make the calculations consistent with the company's occupational injury rate or public reporting conventions. Okay, moving on, let's go to the severity weighting. Okay, the severity weighting is based on score points referenced from the API recommended practice 754 table. It doesn't rank tier 1 PSE levels, but rather differentiate between one level and another. You will see this on the table. There is no judgment that a tier 1 process safety event with a higher severity score is worse than a tier 1 process safety event with a lower severity score. Okay, so why am I doing this? This is done to provide you with a useful performance value information to set your continuous improvement cycle. Let's say for an example, the company wants this year to have 20 score points of PSE severity, okay, in this year. I shouldn't exceed that 20 score points, or I want them to be 0. Okay, so this is just set to give you a reference point, no more, no less. Okay, if you achieve the target, of course, that you have accomplished 20 score points or less, it will be beneficial and an indicator that the process safety system is actually improving. Okay, so let's see the table. I'm gonna zoom in. This table is standard table. Okay, you have here regarding the consequence categories, you have the safety, human health, direct cost from fire and explosion, material release within 1 hour period, community impact, off-site environmental impact. Okay, so the severity points here, you have 1 point if an injury requiring treatment beyond first aid to an employee, contractor, subcontractor, okay? And if relevant to the direct cost, it will be direct cost less than $100,000, direct cost damage will be less than 1 million, okay? So this is a score of 1 point. I'm just saying the example. You don't have to go to all of this. I will attach it as a course reference material, okay? So let's give an example. Okay, a 10-inch process furnace outlet line failed due to undetected corrosion. The rupture released from the flammable liquid is ignited immediately. The fire burned for 3 hours and caused 30 million in equipment damage. There were no injuries, no community impact, and no off-site environmental impacts. So we need to calculate the severity score. We have here no injuries, so 0 points. We have here direct cost of 30 million. So let's see, 30 million gives us, regarding the direct point, I believe here the direct cost is below 100 million. This is below 10 million. Then we have here 9 points. Okay, regarding the material release, all the material were consumed on fire, so 0 points. Community impact, no community impact, so 0 points. Off-site environmental impact, so 0 points. So the total PSE severity weight will be 9 points. Okay, so I believe now that whenever you do the severity weighting or severity weighing, you should consider all of these 5 aspects combined. Okay, you cannot exclude one aspect or one consequence category, okay, and say that only I'm going to focus on the human aspect or the direct cost aspect. No, you should consider all of these 5 aspects. Okay, So the following events are not considered to be a process safety event at all. Okay, here the first one will be releases from transportation pipeline operations outside the control of responsible party. Number two will be the marine transport operations, but here we have an exception, and the exception is when the vessel is connected or in the process of connecting or disconnecting to the process. Number three will be the truck or rail transport operations, and we have here an exception also, is when the truck or rail car is connected or in the process connecting or disconnecting to the process, or when the truck or rail car is being used for on-site storage. Okay. Number four will be the vacuum truck operations, and here the exception will be that if the truck is loading or discharging operations, or the use of vacuum trucks will be as a transfer pump. So this is the only exception that we have. Furthermore, we have the routine emissions from permitted or regulated sources. Number seven will be the office, shop, and warehouse building events, such as office fires, spills, personnel injury, or illnesses. Number seven will be the personal safety events. Of course, we know it, such as slips, trips, and falls that are not directly associated with on-site response or exposure or loss of primary containment event. And number eight will be the loss of primary containment from ancillary, which is auxiliary equipment not connected to the process. Number nine will be the QA, QC, research and development laboratories events. And number 10 will be the new construction that is positively isolated from the process. Okay. Number 11 will be the retail service stations. If you recall, this was also an exception from the OSHA PSM standard. And the last one will be the on-site fueling operations of mobile and stationary equipment. An example for that would be the pickup trucks, diesel generators, and heavy equipment. So I thank you all for your attention throughout the first lecture in module number 3. Stay tuned for the second lecture. So hello and welcome to the second lecture of module number 3 of the Process Safety Management course. At this lecture, we will start with Tier 2 Process Safety Event, or Tier 2 KPI. What is Tier 2 KPI? It's a loss of primary containment with a lesser consequence not reported as Tier 1 PSI. Okay, and of course, it represents a barrier weakness that may be the potential precursor in the future, which means that it may lead to a Tier 1 process safety event in the future. So, Tier 2 KPI acts as the leading indicator for Tier 1 PSE. Okay, so what about the consequences? Basically, they will be lesser consequences than Tier 1 process safety event. Here we have only recordable injuries. Regarding the fire and explosion, the direct costs will be bigger than $2,500 US. Regarding the reliefs, it will be also leading to the same consequences. But here we have the release of a material greater than or equal to the threshold quantities. You will find that on this table, the threshold quantities will be different than Tier 1 process safety events. And here we have another additional level of the process safety event, which is Tier 2-8, which will be for liquids with flash points over 60 degrees centigrade, okay, and less than 93 degrees centigrade released in a temperature below flash points, or it will be for moderate acids and bases. And regarding the definition of moderate acids and bases, it will be for substances with pH greater than or equal to 1, okay, and lower than 2, or pH greater than 11.5 and lower than or equal to 12.5, or more precisely, substances that will cause full thickness destruction of intact skin tissue within an observation period up to 14 days, starting from the exposure time of 60 minutes or less, but greater than 3 minutes. So this is a difference between strong acids and bases and moderate acids and bases. Okay? So regarding the calculation here will be also the same equation applies. Okay, no differences about it. And here I would like to highlight that regarding Tier 1 and Tier 2 process safety events, you can use the help of software assistance. As CCPS, or the Center for Chemical Process Safety, released a free software that can help you better identify whether the event is Tier 1 or Tier 2 process safety event. The software also calculates the PSE rate and severity weighing. The software also has an interpretation models for Tier 1 and Tier 2 KPIs with examples. And at last, the software has a comprehensive list of chemicals for identifying threshold values, packing groups, UNDG classification, and so on. I will attach this free software in the course material. It's very useful. You'll find a lot of useful information and helpful information that will aid your evaluation process regarding the PSEs. Okay? So let's move on to Tier 3 process safety events. And here we are playing in the middle between the lagging indicators and leading indicators. I consider Tier 3 process safety event a challenge indeed, according to the definition, to safety systems. So let's get ahead and start. Tier 3 process safety event represents a challenge to the barrier system that progressed along the path to harm, but stopped short of a Tier 1 or a Tier 2 process safety event consequence. Okay, so it didn't turn out to be a Tier 2 process safety event, or it didn't turn out to be process safety event tier 1. So this indicator or this KPI is intended for internal use only, but can be used, of course, for public reporting as well. And it should be custom tailored according to the needs of the company and the meaningfulness of the operation. Okay? The Tier 3 KPI provides an additional opportunity to identify and correct weaknesses within the barrier system as it is too company specific. Okay? I'm going to enlist some standard examples of Tier 3 PSI. Here we have safe operating limit excursion. We have primary containment inspection or results outside the acceptable limits. We have here the demands on safety systems. We have number 4, other LOPCs not counted as Tier 1 or Tier 2 process safety events, and other meaningful KPIs to the operation. Okay, so as you can see, it can be custom tailored according to your needs. You know what are the best KPIs that can serve the PSM system. You can custom tailor it as long as you provide the adequate characteristics to be effective enough. Okay, so let's get started. What about the safe operating limit excursion? The safe operating limit excursion is defined to be a process parameter deviation that exceeds the safe operating limit applicable to the phase of operation. Okay, so here, if we take this example, we have this tank. It has a high level alarm. Let me just zoom it in for more detail. You have here the high level alarm and you have the low level alarm, and this is the normal operating limit. As long as the normal operating limit is swinging between the low level and the high level, you are doing okay. But what if the level exceeded the safe operating limit, which is above the normal or the high level itself? This is considered to be an indicator. Okay, so what if the excursion took place? Okay, one might say, what if this happens? It means that there is either a fault in your operation or either a fault in setting the parameters for high level. Okay, moving on. What about the indicator data capture? Should be counted only for each time the safe operating limit was excursed, and some companies also calculate the durations. Number 2, if a single initiating event, such as an instrument air failure, okay, leads to multiple safe operating limit excursion, then each excursion should be counted separately. Okay, while if the process condition is abnormal and may lead to multiple safe operating limit excursions, then it should be counted as a single Tier 3 process safety event. And why is that? Because if the process condition itself is abnormal, then you are already going to hover around the safe operating limit. Okay, and it will happen evidently. So no need to count numerous safe operating limit excursion as long as the process condition is a basic cause for such excursion. Okay, moving on to the second category of Tier 3 process safety event. We have here the primary containment inspection or testing results outside the acceptable limits. Of course, as you know, the primary containment include tanks, vessels, and pipes, and so on. Such findings could be corrosion, erosion, stress fatigue that are out of the acceptable allowance. Such findings typically trigger an action such as replacement of kind, repairs, increased frequency of an inspection, or derating the process equipment itself. Okay, so what about the indicator data capture? It should be counted per vessel separately and should be recorded per each pipe circuit regardless of the number of individual test measurement per 100 or per 1000 inspection for test. Okay, so let's talk about demands on safety systems. The demand on safety system is defined to be a demand on a safety system designed to prevent the LOPC or to mitigate the consequences of LOPC. Okay, the system may include preventive elements such as sensors, logic solvers, final control elements, and or mitigative elements such as pressure relief devices, flare scrubbers, and so on. Okay, so the consequences of safety system demand will be either the activation of safety instrumented system to prevent or to mitigate, or the activation of a mechanical shutdown device, or activation of pressure relief device not counted as Tier 1 or Tier 2 process safety event. And regardless the phase of the operation, whether it is startup, shutdown, normal, temporary emergency shutdowns, whatever it is, the demand should be counted. And I need also to highlight that a demand resulting from intentional activation of the safety system during periodic device testing or manual activation as a part of normal shutdown process is excluded. Okay, next slide, I'm going to illustrate how data is captured regarding this indicator. Regarding the activation of SIS or safety instrumented system, you can say that a single, let me just get my laser pointer, you can just say that a single initiating event may result in multiple safety instrumented system activation, such as a wide facility power failure, so each SIS activation should be counted separately. Okay, moreover, the calculation is done as per the number of activation. Okay, and I need to highlight 2 points. And as we said before, that the inadvertent or intentional activation of the SIS during maintenance activities shouldn't be counted as Tier 3 process safety event, but may be counted as Tier 4 process safety event. Okay, moreover, that SIS activation that is configured for equipment protection with no related LOPC protection shouldn't be counted as a Tier 3 process safety event. and this is important. So you have here the activation of mechanical shutdown device. It should be activated when a function is called upon by a valid signal, regardless of whether or not the mechanical shutdown device responds. Okay? We should also highlight that inadvertent or intentional activation during maintenance activities shouldn't be counted as tier 3 process safety event, but it should be counted as tier 4 process safety event. Okay? And the mechanical shutdown system activation, which is configured for equipment protection and no LLPC function, shouldn't be counted, of course, as tier 3 process safety event. Okay? And regarding the calculation should be done as per the number of mechanical trip activations. Okay, the last category here, it will be the activation of pressure relief device, not counted as tier 1 or tier 2 process safety event. And here, the activation is when the system pressure reaches the device set point, whether or not the pressure relief device performs as designed, because it will be an integrity issue. Okay, and we need also to highlight that a single initiating event may result in activation of multiple pressure relief devices, with each pressure relief device activation being counted separately. Okay, so I thank you all for your attention regarding the tier 3 process safety event. Let's move ahead to tier 4 process safety event, the most leading indicator. Tier 4 KPI is named as Operating Discipline and Management System Performance. Okay, it represents the starting point for a thought process that must take place within each company and each facility. The KPI must reflect facility-specific barrier systems, facility-specific performance objectives, and the maturity of existing performance indicators. The features of Tier 4 KPIs are as follows. First of all, the KPIs or the Tier 4 KPIs provide an opportunity to identify and correct isolated system weaknesses. Also, it is an indicative of process safety system weaknesses that may contribute to future Tier 1 or Tier 2 process safety events. It also identifies opportunities for both learning and systems improvement. So let's set some examples. We have here the process hazard evaluations completed. You have also process safety action item closure. You have training completed on schedule, procedures current and accurate, work permit compliance, safety critical equipment inspection, safety critical equipment deficiencies, management of change and pre-startup safety review compliance, completion of emergency response drills, fatigue risk assessments. So these KPIs are only standard examples. You can custom tailor whatever you want in order to better identify your system weaknesses. These are the most leading indicators. If you are fulfilling them, or if you are in a good adherence and compliance, then your feet are on the right track. Okay? So, at last, the reporting of KPIs. The reporting of KPIs should be done annually, okay, by the stakeholders, and it should be reported publicly regarding Tier 1 and Tier 2 process safety events. Of course, we said that Tier 3 and 4 are for internal use only, but you can share the results of them with the public if you want to. The information should be kept for at least 5 years. And regarding Tier 3 and 4, of course, the company should report it to its employees and representatives annually, and also kept for 5 years. I thank you all for bearing with me on this comprehensive academic approach for process safety management. If you have any inquiries or any questions, please send me an email. It's ahf87@live.com. See you later, folks, and goodbye.